Okay, 166, and it's 166 long, perfect. And then finally, instead of doing this for loop, there's actually a library we can use. Markov chain, let's load it. And then we can say, let's do, say just XX is Markov chain fit concat games ppt. Okay, so here's the estimate, which is the one that actually says, okay, here are all of our states. So this first state is a play by Boston, charge foul, 0 points, outcome, 0 possession retained, no, I believe this is shot distance, no shot, no shooter, the fouled was J. Brown, and the turnover type was NA. There are 234 of those. The actual transition matrix we want to look at is this one right here. So ViewXX, $, estimate. I believe the second one's at. Okay. Save this. Okay, so free throw 1 of. Okay, so this says Boston shoots a free throw 1 of, X number. They miss it, points outcome, and they keep possession. They don't keep possession. Or they do keep possession, they don't keep possession. Excuse me, I messed those two up. Free throw 1 of, they make it. Okay, and then we have all of the fouls. Great. Let's just do a quick spot check. Shots. Okay, let's just look up all the shots. And let's look at what the outcomes are. I would expect some offensive rebounds. Okay, so there's actually data in here. Just not seeing any. Okay, so it looks like all the rows sum to 1. Column sums don't necessarily have to be 1. Okay, here's some numbers. So shooting foul leads to a free throw 1 of. So shooting foul 50%, and then 50% leads to, okay, so this makes sense. Shooting foul, A. Baines leads to free throw 1 of, with it missed, so they miss the free throw 50% of the time, and they make it also 50% of the time. Interesting. Sometimes they keep possession, sometimes they don't. Okay, so this is good, but let's see if we can actually, instead of having the, so this is great, it gives us the probabilities. But what we're going to want to do is we're going to want to take this. Nope, this makes sense. So we're going to take these probabilities, and once we have them for every single game, we're going to do some sort of exponential weighting function where this is t time, and this is w for weight. So we're going to say the game that is closest to present time gets a certain weight assigned to it, and the games that are very far away, they get the lower weight. We will probably do this through some sort of exponential function. Okay. So the only thing left to do is say and I know that we're going to run into something right here. We're going to have to say create master matrix that contains all options. So, for example, what I'm thinking of is imagine in one game you have this where Kevin Love takes a shot, he scores 2 points. In other games, say for example, Kevin Love is injured and he takes no shots. So you're going to need to create some sort of way to fill in all the options and just assign zeros to those. I think this is the exact same thing. I'm not sure what I was thinking. Oops. Separating these. And one more thing, I actually made a mistake here. Team. So what we're going to do is we're going to not define this as the game's data frame. We're going to do this actually at the end. So we're going to say, okay, we have all of, I just keep deleting it. $estimate at transition. And so if we want to look only at Boston, for example, we're going to say we want everything, in which case possession is retained. So in which case this 1, 2, 3, 4th item is a 1. Because if it's 0, then everything else will be 0. So we need to figure out how to do that. So keeping it in there is important to do. What is the next play? But we want to strip it out afterwards. I know there's a way to do this through regex.